Hi everyone, esteemed judges and fellow participants. My name is Chow Liang, and here is our proposal for the Shell Selamat Sampai Varsity Challenge 2024. So me and my teammates, Rick Jose Francis and Eng Tze Yee, we are engineering students from INTI International College Penang, and here is our project: Portable Advanced Driving Assistance System (ADAS), specifically for older vehicles. So let me give an introduction to ADAS. It is a system that is popularized during the 2010s, and it is only available in new and high-end vehicles. This also means that the older vehicles that are manufactured before the 2010s does not have the ADAS system. But what exactly is ADAS? ADAS is a system that is able to provide features such as automatic emergency braking or lane keeping assistance. Other than that, ADAS also provides features such as real-time information and automated assistance. So examples for these are blind spot detection and also automated parking. So why is ADAS important and why did we choose ADAS? Based on the research by the Insurance Institute for Highway Safety in the year of 2023, this system has been able to reduce the crashes, especially front-to-rear crashes, down by 50%. Other than that, the ADAS system is able to reduce the pedestrian crashes down by 27%. And the lane departure warning feature is able to decrease any crashes by 11%. Moving on to the problem statements. We want to retrofit older vehicles with modern ADAS technology so that users are able to utilize the safety features of ADAS into their older vehicles without the need to buy a new vehicle. So this helps the users to save costs. Moreover, we have defined three main objectives that determines our success. So the first objective is that we want to achieve the features such as forward collision warning, pedestrian detection, and lane departure warning. The next objective is that we want the ADAS to work even though it is operating at non-ideal conditions such as in the rain or during the night. It's because that it is in these situations where the driver could not see and accidents happen. Our last objective is that we want to incorporate all of these features into one single portable device that is able to cater to different types of old vehicles. And that defines our objectives.
Hi, I'm Rick Jose, and I will be presenting the methodology of ADAS. So methodology of ADAS is divided into three parts: the block diagram, the hardware components, and the software. The block diagram starts from the power supply from the vehicle, the Raspberry Pi 5, the camera, and the output speaker or microphone. The system will begin when the Raspberry Pi 5 is powered up from the vehicle, which will then switch on the camera to provide video and be processed by the Raspberry Pi 5. It will then determine lane detection, object detection, time to collision calculation, and forward collision warning. Once the process is finished, the speaker or microphone will provide sound warning alerts. So moving on to the hardware components, in this project, it has three main components: Raspberry Pi 5 as the main controller, Raspberry Pi camera to integrate with the Raspberry Pi 5, and the vehicle power supply to power up the device, which will then put in a custom case which contain both the Raspberry Pi and the camera. The product will be easy to install and remove as there is only a single wire for connection. So the software in this project is divided into 6 parts. The main language of coding will be done in Python. For object detection, we'll be using the YOLO system, you only look once, which will then detect cars, trucks, bikes, and pedestrians, etc. The lane detection will be done in OpenCV, which is a real-time computer vision using the whole transform method that can be used to find features of any shape in an image. Next, the lane departure warning. When the host vehicle is going out of the left or right lane boundary, an alert sound will go off. For the forward collision warning, it is a time to collision, which is also known as the TTC, where the distance of the lead car is determined, which is used to calculate relative velocity and the TTC. A sound alert when the TTC is more than the threshold only activates when the vehicle is present in the lane boundary. Lastly, the distance measurement will be size-based estimation. Average known dimensions of vehicles such as trucks, cars, humans, and etc. used to estimate distance based on the apparent size in image. The YOLO system, object detection, will classify those objects and calculate the distance based on the height of the object in the pixels in the image. There will be a series of testing to determine the expected outcome of the ADAS. So the first testing is done using the camera, a dash cam available online for different car, model, and condition. Secondly, once the system is robust, it will be carried out for various testing in varied cars and conditions. Lastly, metrics such as detection accuracy, reaction time, and false alarms will be evaluated. The expected outcomes of this project is detection accuracy, reliability, robustness of the ADAS in various conditions. It will also be portability and the easy installation and operation. And done.